Okay, so this is our review session. Okay, and the very first section of review is we will be talking about the real number system and sets. Now, let me start with the zero. Okay, so we all are familiar with the zero, right? This is the most popular number. Okay, the next type of number that we have is natural number, which we also call the counting numbers greater than zero. Okay, so every counting number greater than zero, they are the natural number. Okay, so 1 2 3 4 5 6 7 8, these are the natural number. Now if you combine 0 and natural number, the collection of 0 and natural number, it make a whole numbers. Okay, we call it whole numbers. So whole numbers include 0 and all positive integer. Okay, or whole number includes 0 and every counting number. So that is a whole number. We do have a counting number in negative. Okay, so we have -1, -2, -3, -4, which are less than 0. We call this number as a negative integer. Okay, so our negative integer is negative number. So -1, -2, -3, and so on. These are negative integer. And we have a positive integer, 1 2 3 4, positive counting number. These are positive integer. Okay, and these negative integers and positive integer make a integer. So our integers are numbers without decimal part. So here with -1, -2, -3, with 1 2 3 4, there is no decimal part. Okay, so every numbers without decimal part is the integers. Now there are non-integers numbers. Okay, numbers with a decimal part, these are the non-integer numbers, and these numbers can be decimals, it can be fractions, right? So decimal can be terminating. Terminating means, so if we have a fixed number of digit after decimal, okay, like 0.15, so we have a 2 digit after decimal. Okay, it means this is a terminating decimal. Similarly, -7.52, so after decimal we have a fixed number of digit. It means this is a terminating decimal. Okay, the next type of decimal, we can have a non-terminating and repeating decimal. For example, like 0.3333 and so on. So we have repeating number, so we have a 3 every time, and it's non-terminating. Okay, so these are non-terminating and repeating decimal. In the similar way, -0.111 and so on. Okay, and these terminating decimal, this terminating number, non-terminating and repeating, this all make a decimal. Okay, and decimal and a fraction together makes a non-integer number. Now do you see a difference between integer and a non-integer? So integer are the numbers without decimal part. Okay, non-integers are the numbers with decimal part. Okay, and these non-integers and integers together make a rational number. So every non-integer numbers and integers, we call it rational numbers. Okay, in general we represent our rational number by p over q. Okay, q is a integer which is not equals to 0. Okay, and p is also integer. So if we can write any number in the form of p over q, okay, q should not be equals to 0, and this p and q are integer, then we call it rational number. For example, let's take a number -2. So for example, we have -2 divided by 3. Now, is this number a rational number? What do you think? Is negative 2 over 3 a rational number? Now we compare this number with this form, okay? Now, what is our Q for this case? Q is 3, right? Now, is that 3 equals to 0? That is not equals to 0, so this is good. And our P and Q, now we have P negative 2, we have Q 3. Now, are these negative 2 and positive 3 integers? To be a integers, the number has to be a whole number or negative integer. So negative 2 is a negative integer, 3 is a whole number or a natural number, right? So both of these P and Q are integer, Q is not equals to 0. So this negative 2 over 3 is a rational number, okay? So if we have a rational number, then we should be always write our rational number in this form. Now, there are irrational numbers and the numbers which are not in P over Q form, okay? For example, so let me take square root of 2 divided by 3. Now, why this number is not a rational? Our Q is 3, which is not equals to 0, that's true. Our P is square root of 2, Q is 3. Now, are P and Q integers? 3 is integer, right? 3 is positive integer, 3 is a natural number. But what about square root of 2? Is that an integer?
No, it doesn't.
What kind of number is square root of 2?
It's a non-integer. It's going to be a decimal.
Okay, now we do have rational number, decimal. Now, what is the difference between, okay, now if you use your calculator and find the value of square root of 2, what do we get? So, can anyone help me here? Can you use your calculator and tell me what is the square root of 2 is equals to? It is 1.73, just only 1.73? If it's 1.73, it will be terminating and it will be a non-integer and it will be a rational. But it should not be a terminating here. So what is 1 square root of 2? 1.73. Is it 1.4 or 1.7? Okay, 1.4, 1, 4, 2. We have like so many, like infinite number of digits, right? So here, so that this decimal, is that decimal terminating decimal? No, right? To be terminating, we must have a fixed number of digit after decimal. But we have like so many digit after decimal. Now, is that decimal non-terminating and repeating? Do you see a number repeating after decimal? No, right? So it means this number is irrational number. Okay? So to be a irrational, the decimal is always non-terminating and it's non-repeating. Okay? And this decimal, which is rational, these decimals are terminating and non-repeating, non-terminating and repeating. Now, since square root of 2 is not a integer, square root of 2 over 3 is not a rational number. And we call this number as a irrational numbers. Okay? And the collection of all these rational numbers, irrational numbers make a real numbers. Okay? Or the other way to represent is that if the numbers that can be represented on a number line, we call it a real numbers. Okay? Okay, who can tell me the square root of 9? What kind of number is the square root of 9? Is that rational or irrational? Rational. Now, in what category that square root of 9 belongs? So, what do we call that? What do we call the type of number?
Integer.
Is that that's an integer, right? Positive integer, and it also belongs to whole number, and it belongs to natural numbers, right? Okay. So what about square root of 8? What kind of number is that? Is that a rational or irrational? Irrational, okay. Square root of 8, we can rewrite square root of 8 as a 2 times square root of 2. And our square root of 2 is irrational number, right? And 2 times irrational number, we get the irrational number. So square root of 8 is irrational number. Okay, so this is about real numbers, and you all have seen the numbers. Okay, now the next we have the properties of real number. And the very first property of real number is associative property. And it tells that we can group our numbers in any order when we are adding or multiplying. So whenever you add real numbers or whenever you multiply real numbers, you can group your numbers in any order. It does not change the sum or the product. For example, so if, okay, let's add. Okay, so we have 2 plus 3 times 4. So what is this equals to? Okay, so let me do a sum first. Okay, so just for example, okay, so we have 4 here. So we are adding 2 plus 3 plus 4. So this is 9, right? Now, if we, so we have 2 plus 3 plus 4. Now let's add 3 and 4 together. Now, what will be the sum? We still get 9, right? So if you add these numbers in any order, so if you add 2 and 4 first and 3 in later, you still end up getting 9, okay? So if you add 3 and 4 first and 2 second, we still end up getting 9. It means whenever we are adding any real number, okay, the sum remains same, okay, no matter how you group your numbers. In the similar way, 2 times 3 times 4, so this is 24, right? So this is same as 2 times 3 times 4, which is 6 times 4, 24. Now here, if you multiply 3 and 4 first, and then 2, 3 times 4, 12 times 2, 24, okay, that's the one way. Other way, instead of multiplying 3 and 4 first, if you multiply 2 and 3 first, 6 times 4, 24, okay. So no matter how you group your numbers, adding and multiplying results the same number, okay. So and this property is associative property. The next property we have commutative property, okay, and it tells that we can add our number in any order, okay. That means 2 plus 7 is same as 7 plus 2. Do you all agree? In the similar way, 5 times 6 is same as 6 times 5. Okay, if you switch the position of a number while you are adding or multiplying, the result is always same. Okay, so this is about commutative property. Okay, now let's go to the next property, and we have distributive property. So here, so we can, it means distributive property tells that we can always change we can change sums to a product or product to sum, okay. So here, for example, let's say we have 5 times 7 plus 5 times 6. So we have a sum of 5 times 7 and 5 times 6, right? And this can be written in a product form, okay. So how we write this in a product form? So we have a 5 here common, right? So we can write this as a 5 times 7 plus 6. So we had a sum of two numbers, okay. We ended up writing product of two numbers, and this is our distributive property. Again, we can, if we have a product of two numbers, we can write that as a sum of two numbers as well. For example, if we have -1 times 2 plus 3, we can write, so here we have a product of two numbers. So we have a product of -1 and 2 plus 3. So we have a product here. We can rewrite this number as a sum of two numbers. So we distribute -1 times 2 plus -1 times 3. So here we have a sum of two numbers. Okay, so this is the distributive property. Okay, the next here we have additive identities and multiplicative identities. So additive identities is a very unique number 0. Okay, when you use 0 to add with any real number, you always end up getting same real number. Okay, 0 is just such a number that when you add 0 with any other real number, we always end up getting that same real number, right? 0 plus 5, we get 5. 0 plus square root 2, we get square root 2. And 0 is the additive identity. In the similar way, there is a multiplicative identity, which is 1. Okay, it means when you multiply any number by 1, what we get? We get the exact same real number, right? So square root of 5 times 1 is square root of 5. 10 times 1 is 10. -5 times 1 is -5. Okay, so we call this 1 as a multiplicative identity, and we call 0 as a additive identity. Okay, so these are the basic properties of the real numbers. Now we do have examples here, and we need to identify the real properties here. Okay, for part A, so we have 4 plus 6 equals to 6 plus 4. What type of property is here? You can see here. So what's the difference here? So we have a 4 plus 6 on the left, and we have 6 plus 4 on the right. Commutative, right? So they switch the position here. Okay, and the result is always the same. So we have the commutative property for A. Okay, what about for B? Okay, so for B, we have a product. So 3, we have a 3 times 5 minus 8. So we have a product of two number, and they write product of two number as a difference of two number, and this is a distributive property. Okay, so first one is commutative, second one is distributive. Okay, what about number C? What type of property do you see here? Associative, right? Okay, here they multiplied three different numbers. Okay, so at first they multiplied 3 and 5, then 2. In the second case, on the right side, we have 2 times 3 first multiplied, and then with 5 second. Okay, what about number D? What kind of property is that? 4 times 1 is equals to 4. Multiplicative identity. So 1 is the multiplicative identity here. Okay. Okay, any question up to here? So you should be able to identify the rational number and irrational number. Okay, and once you have that, when we are solving, we'll be using these properties as well. C is multiplicative identity. Okay, so here our 1, so when 4 is multiplied with 1, our result is 4. Okay, and this is our 1 here is multiplicative identity. So it's not a name of a property, but from here we can find what is the what kind of identity is given from this equation. Okay. Okay, now the next number line, you all have seen a number line, right? So what do we have in a at the middle of a number line? 0, right? So we have so this is a number line. So at the center we always have a 0. And what kind of number do we have on the right of 0? Positive numbers, right? So we have positive numbers on the right. And what kind of number on the left of 0? Negative numbers. Okay, so we have negative numbers on the left of our number line. The next set, so this is just a collection of objects, okay, and each object in the collection we call it element of a set. Like here we have a set A, and set A is a collection of a whole number less than 6, okay. So we have a set A, and that set A consists of a whole number less than 6, and we call each of these object in this set as an element, okay. So 0 is one element, 1 2 3 4 5, all these are element of a set A, okay. And we always use a capital letter to denote set, okay. So sometime we might end up with a set with no element, and we call it empty set, okay. So we use this notation for the empty set. We have this phi here for an empty set, okay. So let's say we have a set A, set B, and the A, this is union, okay. So A union B is a set of elements in A or B or both, okay. So here, for example, let me use this circle to denote set A, okay. It does have some element, okay, and we have a set B, and this second circle is a set B. Now A union B, so this is new set, and this new set A union B consists of all the elements from set A, okay, or it consists of all elements from set B, or it consists of elements which is in both A and B, okay. So this yellow region, this common region, and blue region is our A union B, okay. So A union B, it consists of every element from set A or set B or both. So that is the union of our two set. And similarly we have A intersection B, okay, A intersection B. So you see the difference here. So A intersection B, so this is the intersection, this is the union, okay. A intersection B, it consists of the elements which is common in both elements A and B. Yes.
For the union, you don't repeat here.
Yes. So when we are writing the union, yes, you do not repeat the element from set A and set B. Okay. We have some examples here. We'll come to that. Okay. But you have to make sure that you have every element from set A or set B or both, and you are writing without repeating. Okay. And the next we have a intersection, and intersection is the common elements. You are looking for the element which is common for both set. Okay, so here we have an example. Okay, at first, so in part A, what are we asked to find here? So we are given set A. Set A consists of elements -2, -1, 1, 4, 5. So this is our set B, this is our set C. So what is A? Is that the intersection or union? So what is this? Is the union, okay? So you are writing every element. So here we are asked to find B union C, and you are writing every element from B or from C or the element which is common. But make sure do not repeat, okay? So let's collect every element from B or C, okay, without repeating. So let's write from -3, we have -3, then let's do -2, 4, 7, 9. Now let's go to C. So we have -3, but we already have a -3 here, so do not repeat. Now next is 0, so we don't have 0, so write down 0. Next is 2, we don't have 2, so 2, and we already have 7, so do not repeat. So all these elements, okay. So you are collecting every element from set B, from set C without repeating, okay. So first you just write down all element from B, and you look for the element which is not common. So -3 is already here, so we did not repeat here. Similarly, 7 is already in B as well as C, so we just write down once. And this is the union, okay? Okay, for part B. So for part B, what we are asked to find? We are asked to find A, this is intersection, okay? So A intersection B. So it means we are looking for the elements which is common, which is same in set A and set B. Now can you tell me the elements which is common for set A and set B? What do we have as a common? -2 and 4, right? So we have a -2 here, we have a -2 here, we have a 4, we have a 4. So every common element is the intersection. So A intersection B is -2 and 4. Okay, for part C, so we want to find intersection of a set A and C. So we are looking at set A and set C. So this is our set A, this is our set C. We find the element which is common on these two sets. And what is that number common? It's not like it's an empty set. Okay, so our empty set. You can use this as an empty set, or you can just write down the braces. Okay. So this is how we can find the union and intersection of a set. Does anyone have any question up to here? Finding union, intersection. Okay, so let's go to the next here. Okay. Now, so we have a interval notation. Okay. So let's start with this interval notation. So here we have a bracket A and B bracket. Now how do we read this number? Okay, so let me use like a specific example. For example, if you have a 4, 6. Now, how do we read this number? Like, how do you read this expression? So what does this tells you? Is it a collection of numbers? It is a collection of a number. Okay, now what kind of number is in this set?
Positive number.
Any positive number, like, so if it's 1 here.
Positive numbers between 4 and 6.
Okay, how many numbers do we have in between 4 and 6? 2.
No.
One.
Okay, so who can tell me how many number we can find in between 1 and 10? So in between 1 and 10, how many numbers we can find? Is that the only number we can find in between 1 and 10? So what about 2.5? Does 2.5 belong in between 1 and 10? What about 1.3333? 9.999. So it means we have a infinite number, right? So in between 1 and 10. So if it was like how many natural number is there in between 1 and 10, then you count 2, 3, 4, 5, 6, 7, 8, 9, right? But I'm asking numbers. So numbers can be rational, irrational. So how many rational or irrational numbers we can find in between 1 and 10? It is always infinite. Okay, we can't make a list of those numbers in between 1 and 10. Okay, now since we can't make a list and write in a set like this, okay, so here, so in this example, we had a set A, and set A consists of all whole numbers less than 6. And we can make a list of those numbers which are less than 6, right? So 0, 1, 2, 3, 4, 5. But if you are asked to write down or make a list of a number less than 6, so if you are asked to write down the number less than 6, how do you write down? Is it possible for you to make a list of every number less than 6? No, right? It's not possible. So in that case, we use a interval notation, okay, or we use a set notation. Now let me start with this first set notation, okay. So here we have a number, okay. So this is a set of a number, okay. So this is a set of number. It has an infinite number which is greater than or equals to 4 and less than equals to 6. So if you have a bracket, okay, you are including this end number, okay, you are including this end number on your set and every number between 4 and 6. So we have a bracket on both sides, okay. So it means in this set we can find 4, we can find 6, and every number in between 4 and 6 are in this interval notation, okay. Now in a set notation we have, so we call every number in between these two numbers as a x, and in a set notation we write this x such that, so this is such that, okay, we read that as a such that, so x such that our x is greater than equals to 4, less than equals to 6. So every number, okay, which is greater than, so this is greater than equals to 4 and less than equals to 6 is in this set. Now in a number line, how do we represent this set? So we have a number line, okay, we have a 0, so our 4 and 6, they both are on the right side of 0. Now since we have a bracket on both sides, we will use a closed circle at 4, closed circle at 6. Closed circle means you are including these two numbers. So if you have a closed circle, you are including this 4, you are including this 6, okay. And every number in between 4 and 6, so every number in between 4 and 6, so this is this set here, okay. So if you have a bracket, make sure to use a closed circle, okay, and you always include these end numbers. Now instead of bracket, if you had parentheses, okay, so let me take, so for example, if you have 4, 6 parentheses. Now what is the difference here? What difference do you find in between these two sets?
4 and 6 are not included.
In the second one, right? So yes, so we have a parenthesis here, we have a bracket here, that's the difference that we can see. And having bracket means you are including your end numbers, okay, and if you have parenthesis means you are excluding end numbers, okay. This set does not consist 4 and 6, but it consists every number in between 4 and 6. This set, it consists 4, it consists 6, and every number between 4 and 6. Now in a set notation, we write this as a x such that x is greater than 4 and less than 6. There is no equals to sign, okay. So this is it consists of a number x. X is any number between 4 and 6, okay, and that x is greater than 4 and less than 6. So it does not have equals to here. So if you have a parenthesis, there is no equals to, okay. If you have a bracket, you always have equals to. Now in a number line, so how it looks like? So in a number line, so we have a 0, we have a 4, we have a 6. Now what do we use as a notation if we have a parenthesis? We use a open circle. We use an open circle, and every number in between 4 and 6, that is this set. If you have a bracket, it's always closed circle. Okay, if you have a parenthesis, it's always open circle. Closed circle means you are including that number. Open circle means you are excluding that number. Okay, if you have a equals to here, you are including. If you do not have equals to, you are excluding. Okay, let's do one more example. Okay, so now can you tell me any number? Okay, so let's say we have -2 to 0. Now how do we read this number?
All real numbers in between, or all real numbers equal or greater than -2,
And
or equal or less than
it has to
0.
be and. So this is a set of real numbers, okay, which consist of all numbers which is greater than equals to 2 and less than equals to 0. Okay, so if you have a number which is equals to -2 and greater than 0, or equals to 0 and less than 0, it consists, this set consists of those numbers. Okay, so here we write in a set notation as a x is any number that we are using to represent in general. So x such that our x is greater than equals to -2 and less than equals to 0. So every number in between -2 and 0, including -2 and 0, are here, are in this set. Now how do we draw a graph for this one? So you draw a number line. We have a 0. Now we need a -2. It's on the left. Now what circle? Do we use a closed or open? Close, because we have a bracket here. So we have a bracket with -2. So close at -2. We have a bracket with 0. So close at 0. Now any number in between -2 and 0, it means this portion. Okay, so every number which is -2, 0, or any number between these two numbers are here. Okay, this is our interval notation. Okay, and we will be using this interval notation a lot. Okay, you should be able to write down this interval notation. Now let's go to the other type here. So here okay, we did parentheses a and b. Now so let me take a same number. So what is now, if we have -2 to 0, we have a bracket here, we have a parenthesis here. Now what's the difference here? So how these two are different? How these two set are different?
The one should be 0.
Now does this set include 0?
Yes.
Yes, right? We have a bracket with 0. Now does this set include 0?
No.
We can see here 0, but there is a parenthesis. It means you are excluding this 0. Okay, every number which is greater than equals to 2 and less than 0 is here. So we can write this as a set of x such that x is, so we have a bracket here. So you always write down, make sure you have equals to. So greater than equals to -2, and we don't have a bracket, we have a parenthesis, so it's strictly less than 0. Okay, now for a number, for a graph, we have a 0, we have a -2. So with -2 we have a bracket, so we are using closed circle. With 0 we have a parenthesis, so open circle, and every number in between -2 and 0. So this graph is for this set of number. Okay, now can you try -2 parenthesis -2 and 0 bracket? Can you write this interval notation in set notation and in graph? So write down this set as a, this is a set notation, this is an interval notation, and this is a graph. Okay, so write down that interval notation in a set notation and draw a graph. make sure to save every numbers, okay? And you have to save. Yeah. You need to color that save. So here we have a parenthesis on the left side, bracket on the right side. So you start with x as that. Now we have a parenthesis on the left side. Okay, so x greater than, there is no equals to -2. On the right side we have a bracket, so less than equals to 0. So this is a set notation. In a number line, so we have a -2 here, we have a 0 here. Okay, at -2 there is a parenthesis, it means open circle. At 0 there is a bracket, so closed circle. Okay, and the number in between -2 and 0 is this part, so you have to set this part. Okay, so this is a graph for this set notation. And every time if you when you write an interval, you always have your small number on the left and a big number on the right. Okay, so if we go back to our example, so we have -2, 0. So -2 is small, 0 is big. And if we go to our previous example, so we have 4 small, 6 big. Okay, every time, okay, you are writing your small number on the left and big number on the right. Can you think of a number? Okay, for example, if you write your interval as a, okay, let's say you have a 0, -2. Now, according to definition, how do we read this number? So every number which is greater than equals to 0 and less than equals to 2 is here. Can you think of a number which is greater than equals to 0 and less than equals to -2? Do we have any number greater than equals to 0 and less than equals to -2?
A whole number?
Yes, any number, like decimal, whole, fraction, whatever number, but it has to be greater than 0 and less than -2. There is no number, right, which is greater than 0 and less than -2. But we can find infinite number which is greater than 2 and less than 0, right? So if you take -1, so -1 is greater than -2 and less than 0. So we can find -1 here. But we can't find -1 here because -1 is not greater than 0 and is not less than 2. Okay, so every time whenever you are writing an interval, make sure to have a small number on the left and big number on the right. Okay, so if you write your interval this way, this is not correct because it's an empty set. So make sure always a small number on the left and big number on the right. Okay, now so sometime, so for example, okay, let me start with a graph. So we have, this is 2. Now on the left side of our number line, what number do you see? So if you just, okay, sorry, so it can't be +2, right? It has to be -2 on the left. So this is -3, -4. Okay, now if you keep writing on the left, so how do we represent a number on the left? So it's going to be a very small number, right? So it's not possible to write every number. So in that case, to represent that very small number, we use -infinity. Okay, so -infinity is the notation for the very small number. In the similar way, on the right of 0, if you make a list of every number on the right of 0, and on the right side, we will get a very big number, and to represent that very big number, we use +infinity. And every number in between, so every number from -infinity to +infinity, what do we call this number? All numbers from -infinity to +infinity, these are real numbers. Okay, So every numbers between negative infinity and positive infinity, these are real numbers. And if you have infinity, you always use parentheses. You do not use bracket. Okay? If you have an infinity, it's always parentheses. Now, why is that? So what does it mean if you have a, so why you can't have a bracket here? So if you have a bracket, it means you have to include negative infinity, right? Now what number is that negative infinity? Do we know what is negative infinity is equals to? We know this is very small number. Okay, it is a representation for a very small number, but we don't know what number is that. Okay, so keep in mind every time is positive with positive infinity, negative infinity is always parentheses. Do not use bracket with infinity. Okay. All right. Let's do this much for today. The remaining